Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So would you believe that I 3D printed all of these blocks? No, of course I didn't. These are, I think it's wood, some sort of material that is related to or comes from trees. I'm not entirely sure how that process works, but I believe there are other channels that cover that. So this week we're going to be helping out a friend of mine, actually a friend of the channel, I guess, as well. And I believe she's helping out with preparations for a baby shower, and they're going to do some sort of project where they're going to be painting these blocks. But what she wants to do is have letters engraved on opposite sides of the block. So as I understand it, we'd have a letter here, and we would have a letter here. So imagine a letter A over here, and then on the opposite side of the block, there would also be a letter A. And then I think they're going to paint on the other sides. I'm not entirely sure of the details, but that is why, say for example, just buying a set of like baby blocks would not work. These are going to be very similar to that. We're only going to have letters on two sides. And she reached out because she's seen the toys we have here in the shop and was pretty sure that I had some machine that would provide marking on this. And I think we could do this with the X-Tool laser. But what I'm worried about is, let's see, there's 26 letters in the alphabet. We got to engrave on two sides. That's 52 engravings. I'm not looking forward to aligning all of these blocks. Let's go over to the laser. I'll show you what I mean. Okay, we're over here at the X-Tool F1 Ultra, and we're going to be using this machine because it is both a fiber laser and a diode laser. It's basically two lasers with one galvo head, because fiber lasers are great for metal and plastics, but they don't really do much on wood. And diode lasers, while they don't do a whole lot on metal or plastic, in fact, they don't do really anything on plastic other than melt it, they do great on wood. So we're going to need to use the diode portion of this machine to engrave these. But the problem that I am foreseeing here is, let me turn framing on. Okay, so I turned on framing. Let's see if we bring our block back in here now. You know, it's not too difficult to get this kind of lined up where it looks like that. The free space on each side of our rounded rectangle is about equal. I do have to look at it from the front and kind of both the left and right sides because this is just not very high contrast. So it is a little bit tricky to see. And then we would need to do that for the opposite side of the block as well. So we'd be doing that 52 total times. And we would need to open up each one of the letter designs individually. So we'd be opening up 26 individual files. Now, this machine did come with this little fence, and we could screw this in place here. And I think that would certainly be a step in the right direction. We just have to make sure that our design is always in the exact same place in the X-Tool creative software. But each one of these blocks is slightly different in size. So we wouldn't necessarily be centered just by having this one L. Now, maybe if we had two of these and they were the exact right size, or these holes were in the exact right position, that wouldn't be so bad to try and split the difference. But I think we're still going to have to do some tweaking. I think there's an easier way. What I've seen folks that do a lot of production laser work, and that's never going to be me. I mean, these machines really just serve as another tool in the arsenal to mostly mark 3D prints, but I've done some cutting work on these as well. But they make jigs for everything. So that's what I want to try doing. I think it's going to be a fun exercise. I don't think it's going to be terribly difficult to do, but I think we can fit, I bet you, at least 6 of these up here. Let me go get some more blocks. Okay, 4 for sure, no problem. You know what? I think we could probably get, yeah, I think we could do 9 at the same time. So imagine if we design a jig that we can drop 9 of these in at a time. We would do the engraving and then just take each block, pick it up, flip it over, set it back down, engrave again. So see, 9, I think that's only, what, that's 3 plates? Yeah, so we'd realistically only need to have 3 design files and set up the blocks 3 times, flip them. So we'd have basically 6 total setups. All right, let me get some measurements of this and start trying to figure out what this jig is going to look like. All right, so I came over here to measure this, and the measurement that I'm looking for is the distance between these 2 threaded holes, and then same thing, this measurement here. I'm assuming this is probably a square grid of threaded holes. That would make the most sense. but I want to confirm, and I want to use the outermost holes to mount this jig. I figure even if we don't need it to be that big for this project, and we probably do need it to be almost that big at least anyway, but if I'm going to go through the trouble of designing a jig to sit on this table, I could probably reuse the majority of that work for other objects as well. I'm really only redesigning the center part where stuff's going to sit into. So I thought, okay, well, let me get these measurements, confirm it's the same front to back as well, and I'll design the jig around that. Well, this here is 6-inch calipers. These are the ones that I have here in the garage, and of course they don't open that far. Now, in this specific scenario, I think there's other ways that we could resolve this. I'm going to guess that these are probably drilled fairly accurately. So we could just figure out what the center to center distance is of any two holes on the table, do the math, and figure out exactly what distance they are apart. However, I got some Christmas presents to help with measuring larger stuff, and I want to share them with you guys. So this is a 600 millimeter long stainless steel rule by a company called Shinwa, and they're out of Japan. And in fact, I think, yeah, it actually says made in Japan right on it. Now, they make a whole bunch of different models of these. I will share the specifics of this one, but the key features I really like about this particular one is that it has this satin finish. I don't know if the camera is doing it justice, but it is really, really easy to read because it is not super reflective, but it reflects enough light that you get a strong contrast between the metal background and the black markings. Like the back of it is polished. And yeah, I don't know. I mean, I guess it looks pretty, but it's super hard to read. Whereas the satin side is really, really easy to read. So now if we take this guy, we can pop this down here, and I can see right away that it falls right at 210 millimeters. And if I confirm the distance between two of the holes, yeah, they're right at 35. So that was not particularly hard to measure. But let's go back over to the workbench. I'll show you some other tricks up the sleeve for using these to measure longer distances. So this is the first one of these that I had, and I have no recollection of where this one actually came from. This is 300 millimeters in length. It's not my Amazon purchase history. I don't know, maybe it came with something, but this was my favorite of all the different steel rules that I have because of that satin finish. It's just super easy to read, really nice high contrast. But it certainly measures longer things than my calipers, but I was still running into issues where it wasn't long enough. So I put the 600 millimeter length version one on my gift list and got this for Christmas this year. Almost put the 1 meter length one on, but I noticed they get wider and thicker the bigger you go, and it just seemed like 100 millimeters, or 1,000 millimeters, sorry. 1 meter might be really more than I need. I think the 600 is just sort of a good compromise length for the type of work that I do here in the shop. Another thing I found while searching for these to put them on my Christmas list was this. Shinwa actually makes one of these for each one of the widths of their stainless rules, and this slips over the end, and there's a thumb screw on here that tightens down to lock it in place. And I'm glad I tried it because it makes measuring things that you're trying to get like the width of it a lot easier. Let me show you. All right, let's measure the length of this here just to kind of demonstrate. So if I take this end of the rule and I just rest that right up against my finger, so I know that this end is right at the edge, I can slide this guy over and just bring it right to the edge of the material. And even if I can't get my eye down there, like let's say it's in a weird spot, it's just hard to see, I can lock this in place. And now I can pick up the rule and I can look at exactly where the closest line that intersects that, and even if it's not right at one, I can kind of infer, is it halfway between the line and the next line? And you can actually get pretty darn accurate. Oh, and while we're at it, I think I've shown these to you guys before, but this is just this giant set of like old school calipers. And I said, if you ever see a set of these at like an estate sale or a market or something, pick them up. In fact, I guess they probably still make these new, and I bet they're not that expensive. But this is like an old set, or at least I'm assuming it's pretty old based on the way that it's made. And honestly, I did originally buy it as like just a decoration. I just thought it kind of looked cool, but I use it quite a bit because it opens up really, really wide, and things that you can't just set the rule down on or use a measuring tape for, like let's say you wanted well, let me grab some, I'll show you. All right, here's a bucket. Let's say that we wanted, for whatever reason, we wanted the diameter of this dimension on the bucket down here. Not this one up here, but this one down here. Now, there's probably some creative ways we could do that. We could probably measure the diameter of this top portion and then maybe have like a steel square coming down, position it against this, and then measure the gap between this and that. I mean, I'm sure there's ways to do it, right? However, if you have a giant set of calipers like this, we can just position these on here, find the point in which they just start to tighten up as you go across that dimension. And then take these, set them down on the steel rule, and you can take one edge and put it against the end of the steel rule and swing them over, and then you're essentially reading on the rule where this finger of the caliper is, and that's your diameter for that dimension. Now, yeah, are there other ways to get there? All right, I just can't help myself. Thinking about measuring the circumference of this one and calculating the dimension reminded me of this guy. And this is something else I want to share with you guys quick. This is another gift I just got for Christmas this year off my wish list. And I can't take credit for this one. I think I saw this on John Crane's YouTube channel. And this is made by a company called FastCap. And this is their flat back metric standard. Well, what does flat back mean? Well, check this out. It's not a standout tape. It's just a flat tape. It's still steel. Still a steel tape, so you can't bend it sideways. You know, it's not going to stretch out. It's going to retain its accuracy. But look at this. It'll lay flat out. And it's also great for wrapping around things. It's like if I had to measure the circumference of this, this is what I would use. Because it's not going to stretch. It's not going to try and spring away from me. It's great for measuring irregular shapes like that. All right, and here is the design that I came up with for this. And yeah, this is probably a little bit fancier and possibly more complicated than it necessarily needs to be, but such is the way of things on this channel. And, you know, I did want to make sure that, you know, I'd be able to reuse, for example, the thumb screws that are on that little L-shaped fence that came with the machine, because they'll always be over there with the machine. I'm not going to have to go looking for hardware. So, for example, the specific height of these pads here that get secured down to the table of the machine are just the right height that it should work for the length of the threads on those thumb screws while still getting a good amount of engagement and snugging up. The blocks are obviously evenly spaced apart, and I possibly could have gone a little bit shorter with the sockets for the blocks. I believe these are 15 millimeters deep before we get to that bevel. The blocks are 50 millimeters in height. I want to make sure that they're firmly in place. I think the ones that are a little bit loose, you know, are probably not even going to contact the sides, and that's just fine. But I fear that if we only had, say, maybe 2 or 3 millimeters, that they'd have more play in them, because the blocks might be a little bit rounded on the corners or the bottoms, or you know, maybe the sides are slightly out of skew. I want to have enough depth there in the sockets that they should be held fairly square. And, you know, did we need to have this section that's raised with a bevel? I don't know. No, we probably could have just made this whole section higher. But, you know, that said, I wanted to reuse as much of this geometry as I can for future jigs. You know, if you imagine everything that's raised here, so this whole section up here at the top, if that's gone, as are the recesses for the blocks, we're left with just this flat face here. And I can take that and basically have that as a starting point for any other jig that I want to build for this machine, for other objects that I might put in here that I'm doing multiples of. So, all right. Let's get this printed out and see if stuff actually fits. All right, and our print is complete, and it looks pretty good. The lettering on the side came out pretty nice. It's not as high contrast as I would like. I mean, we could have done that multicolor, but this already took like, I think 5 hours and 20 minutes or something to print. So this would be an eternity if we did that multicolor. I guess we could laser engrave it, but you know, who am I kidding? I'll probably never use this thing again, but let's see if the blocks fit in here. All right, I grabbed 4 random blocks out of the box. Ooh, that's snug. Does go and comes out. I mean, we want snug, but I'm a little worried. If there's blocks that are bigger than this one, that might not be so great. Okay, that one fits easily. Yeah, so does that one. So does that one. So, all right, this one, maybe it's just the way I set it down in there, because now that one seems to fit. Now that side's a little snug. Let me grab a couple more. All right, I think that's going to work. So let's take it over to the laser and see if it actually fits on the bed of the machine. All right, I designed this to reuse these thumb screws that are already in this little fence guy. This doesn't really matter, but I kind of want the lettering on the front. All right, that fits on there really nice and feels nice and flat as well, like I don't feel it rocking around at all. All right, they are slightly more snug than I would like. I mean, they fully seat down in there, but some of these are, like, that's the fit that I like. Some of these are tight enough that they're probably going to be, like this one. This one is going to be a little bit of a pain to get in and out, but it does get it. It does come in and out. It's just a little bit, yeah, see, now that side's a good fit. So, all right, I don't think it's worth reprinting this to provide a little bit more space. I think as long as they're all sitting down flush on the bottom, we should be good to go. But now we actually still have to design, I guess, well, not design the artwork. She sent me the artwork for this, but we have to figure out how to align the artwork to this same grid. All right, so here's what I'm thinking. Here's our design of the jig. So if I take just the geometry where the blocks sit and say the geometry of the bottom face, if I take that and I duplicate it, and those are not going to be at the same height, so we'll drop these down. Set them on this face, and we'll delete these faces. We also don't need these holes on the sides. There we go. So now if I take basically this face where this collection aligns, one or the other, and I export that as a DXF, we should be able to just pull that into our Xtool creative software and position the designs inside of the space of these squares, because that should basically force us to align the design with where the blocks are actually going to sit in the jig. All right, this is working out really well. I imported the DXF with the template and I actually locked that, so even if I try and select this, I can't accidentally move it around. And then I imported the artwork for each one of the individual letters, and I can just drag them in then, find the sweet spot where it centers up on the squares, drop it down, and I'll save this. I'm going to have to do this 2 more times for the rest of the letters in the alphabet. I'll have 3 total of pages like this. I'll save each one off, and then we should just be able to open them one at a time, and we'll just run the engraving job twice. So once for one side of the letters, we'll flip all the letters over, engrave again, and then move to the next file, same thing. Engrave one side, flip them over, and we should be able to get through these pretty quickly. All right, I loaded up the design for the first set of 9 blocks, and everything appears to be lining up exactly right. So I guess let's go for it. All right, well, that looks great. But it also took about 40 minutes to do, so I didn't even consider that when I thought about doing these one by one. I'm really glad that I made the jig, because we got 40 minutes, so we have 3 sets, 2 sides. It's going to take 4 hours to engrave these. I did not do the math on that when I started this. So yeah, at least I don't have to stand here and swap blocks for 4 hours. I'm only gonna have to come back every 40 minutes and just keep an eye on this in case it is starting a fire. But that looks really good. The depth on these, I could probably do less passes, but I do really like the depth on that. Like, that is nice and deep. Probably about maybe 0.7 millimeter in depth. So. All right, I got to flip all these over and run this one again before we start the next set. All right, guys, that was about 4 hours worth of work to get all these engraved, but I am really happy with the result that we got on these. And I did actually have to redo a couple. I don't know if you guys caught it, but when I flipped over the F, there's a pretty big knot on this side. And, you know, I thought, hey, that's characteristic of the wood. I'll leave it. But the more I looked at it, the more I thought, that's probably one we should have rejected. So I redid that one. And the W, all these blocks are slightly different sizes, but the W is a really big difference. I don't know if you guys can see the height difference there. It's almost like they ran out of wood and just went with it anyway when they cut this block because, yeah, it's a big step there. So I decided to just redo that one. And I also did an extra one for a friend of mine. You'll have to tell me down in the comments if you recognize who this guy is. Guys, as always, thanks for hanging out in the shop with me for today's design and build. And if you've done jigs like this in the past for either laser engraving or CNC engraving or any other kind of work where you're building jigs like this, let me know in the comments. What kind of work do you do? What maybe mistakes did I make with this one that worked okay for this project but aren't going to work great for the next one? Or, you know, even if you've never made one of these, watching me do it, what might you have done differently? If this is by chance your first time here on the channel, this is all we do. It's all functional printing. We don't do any doodads of the week or any multicolored junk, minifigs or anything like that. It's all design and engineering and functional prints. So if you like that sort of thing, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.